Okay, so we're talking about simple Bohr models. Simple Bohr models, these are the ones that you've already done in the 8th grade, most likely. And Niels Bohr created these simple Bohr models using a lot of math. And this math was based on electromagnetic attraction of electrons to the nucleus and where he thought they would most likely be found around the nucleus. Niels Bohr, the one mistake he made was assuming that electrons were always particles, which we found out later with Werner Heisenberg and some other, Max Born and some other famous physicists about quantum physics, okay? But Niels Bohr's idea in his basic model was 100% correct. And we know that because the models he created fit perfectly into the periodic table. That's basically the game that we just did yesterday. With the circles and the dots, those are Niels Bohr's diagrams. And when he came up with them, and he laid them on the table, they fit perfectly. So you would have to assume you were correct, right? And that was definitely, seeing that his patterns fit the patterns in the periodic table, definitely helped him publish the paper and feel good about it, right? You would feel like you were correct. Okay, so on the periodic table, you remember that game board was the top 3 rows. And so hydrogen, helium, lithium through neon, sodium through argon. Argon's number 18, right? Now we know from looking at the game board, what would a Bohr model of silicon look like? How many circles would it have on it? 3, that's right, it would have 3 circles. And then how many outer dots would be on it? 1, 2, 3, 4, boom, right? So no longer are we doing the 8th grade math, we're looking at a model going straight to the table and being, boom, that's where it would fit. That's what it would look like. Does that make sense? So let's take a look at how the model is created from the ground up. Right, you guys all have a piece of paper. And the people at home, they won't necessarily have this piece of paper. All right, here it is. Boom, 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 boom. I want you to, in the middle of your piece of paper, I want you to draw a circle about the size of a golf ball. And on that circle, you're going to put 2 tags, or like 2 empty spaces. Okay, so this is the sheet of paper, and we're making a circle with 2 tags, or 2 empty spaces. All right? Then, outside of that circle, right, the next circle, I want you to draw another circle that's a little bit bigger than a baseball maybe, okay? And how many tags or open spaces are we going to put on that? We're just drawing the squares. How many squares are we going to draw on this? For the second ring, how many squares are we going to draw on it? Going to draw 8, right? Now, why would we draw 8? Let's look over here at the periodic table. If you look at the periodic table, there are 1, 2, 3, 4, 5, 6, 7, 8 elements in the second group. So that means when we look at, when we look at the Bohr model will have 8 empty spaces in the second ring. The Bohr model is literally the periodic table. Now, most of the time in 8th grade science, you're just taught to put circles and dots. But now we're seeing that these circles and dots are the periodic table. Right? That's what the Bohr model is. It's a circular model of the periodic table. Okay, so we're now going to draw a third ring that goes out near the edge of our paper. And since this is the third circle, how many open spaces will be on it? in the third circle? How many open spaces will be on the third circle? Okay, let's take a look at the periodic table. Let's go down to group. Let's go down to period 3. How many elements are in period 3? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so period 3 is the third ring of your Bohr model. So that's the same thing. So if 1, 2, 3, 4, 5, 6, 7, 8. All right? So this is the periodic table, right? This circular diagram, or the Bohr model, is the periodic table. Let me, now I'm just erasing your piece of paper because I've shown you how to draw it. Take a look at this, very simply. If I put up here on the board a picture of the blank periodic table. I can find one here really quickly. Look over here, the blank periodic table. Then you will see that as we go down the periodic table, the Bohr model literally matches it. So I'm going to pull this down. And you'll see the first row right here, or the first horizontal row, or the first period, has 2 squares in it. Well, those are these 2 squares. Okay? The second period of the periodic table has 1, 2, 3, 4, 5, 6, 7, 8 squares in it. Well, guess what? Those are these 1, 2, 3, 4, 5, 6, 7, 8 squares, right? And then when we get down to the third period, 1, 2, 3, 4, 5, 6, 7, 8. Then now we look at our Bohr model. 1, 2, 3, 4, 5, 6, 7, 8. Right? So this is the periodic table. That's what's great about it. Right? Now there's only 2 rules. There's only 2 rules to creating Bohr models. And here they are. If you can draw your little empty game board, if you can draw this, then all you have to do is, as you add electrons to it, or as you add game board pieces, you start on the inside. That's rule number 1. And then rule number 2 is, you can't move out until the ring is full. Okay? Those are the only 2 rules. So check this out. You guys have game board pieces right there. I'm just going to use my marker. I want you to add 5 pieces to your Bohr model, to your board. Add 5 pieces following these 2 rules. Start on the inside, and you can't move out until the ring that you're on is full. So right now, add 5 pieces to your game board. It'll only take you a second. You added 5 on there? Okay. All right, here we go. I'm going to add 5 pieces. Ready? 1, 2. Now, I started on the inside. 1, 2. And now I can't move out until the ring's full. That ring is full. Now 3, 4, 5. Now, where these next 3 are is not important. I just try to keep them spread out because they're all electrons and they all have negative charges, so they're all going to be staying away from each other, right? So how many pieces are on your inside ring? 2. How many are on the next ring? 3. So if you look at this, this is a Bohr model of boron. Boron is number 5 on the periodic table. And if we look at this, it's 2 and 3. So follow me over here. Meant to do that. So follow me over here. There's 2, boom, boom, in the first circle. And then in the next circle out, we're down here to the next row, there's 3. 1, 2, boron. 2 and 3 is boron. Does that make sense? So what you need to do when you do a Bohr model is make sure that you write, after you do your Bohr model, you're going to write 2 over 3. What's this number always going to be? Yeah, it's always going to be 2, right? If the atom is any bigger than helium, right, then this number is always going to be 2, and then next, right? Let's try this. Add pieces to your game board until you have 10 pieces. We got to start on the inside, and we have to work our way out. So we're going to add 10 pieces to this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay, that's convenient. I've got 2 in the innermost ring, and now 8 in the second ring. 2 and 8. 2 plus 8 is 10, so this is going to be neon, because neon is number 10 on the periodic table, right? Let's take a look up here at neon. Look up at neon really closely on the table. Okay, look up really closely on the table. And look just beside of neon. Look right here. Look what's written there. 2 and 8. That's literally those 2 numbers are from the Bohr model. That's from the model of electrons in the atom. So all down the right-hand side, these are the numbers that tell you the Bohr model of these elements here in red, the noble gases. So this is literally showing you how to build the Bohr model. And we're going to do a 1 through 18 today, but you can see as you get bigger, it gets more complicated. Look, 2, 8, 18 and 8, 2, 8, 18, 18 and 8, 2, 8, 18, 32, 18 and 8, etc. So they do get bigger, all right? And they get slightly more complicated. But today, we're just going to work on these elements, okay? So I've posted it to your Google Classroom, and there's 12 elements for you to do, and you're going to do 6 per page, all right? And then you're going to turn them in by taking pictures and submitting the pictures, okay? All right.